Alright, today we're going to start on page 85. But before we get to this, I'm going to review something else. So page 85, we're going to be partitioning a segment. Okay, partition, I-N-G, partitioning a segment. But before we get to page 85, I want to look at the side splitter theorem. That's where I want to go look at. So before we get to page 85, let's take a pit stop on page 79. Okay. So, side splitter theorem said on page 79, when three or more lines are parallel and the transversals intersect the lines, then the parallel lines partition the segments into equal proportions. So the proportion of 4 to 5 would be the same proportion as 8 to 10 over here. Okay, so we're going to use this idea of the side splitter theorem today when we talk about partitioning segments. Okay, and we're going to do something that looks really hard, but actually it's going to come out to be pretty darn easy. So what page number am I doing here? 85. Okay. Okay, our objective today is to partition a segment. Okay, so I'm going to do this problem. Let me make sure I have the problem that I want. It's going to be segment AB has endpoints at A and B 15, 0. Find P such that find P on AB such that AP compared to PB is in the ratio of 3 to 2. Okay. So here's how we're going to do it. We're going to graph this. The best way to look at it is to graph it. Okay. So I'm gonna go ahead and make my graph here. This feels a little wonky. I'm going to make a graph of what's going on here. Okay, so here's A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I should put this down a little bit. So you're going to mark 10, that's 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's A. And then B is going to be over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's B. And here's my line segment. So essentially what I'm doing is I need to divide this line into two parts so that P somewhere on this line is, so that AP to PB is in the proportion of 3 to 2. That means the length from A to P will be longer than the length from P to B. So I'm thinking that P is going to be somewhere in this area right here. Okay, that's my estimate. Since it's in proportion of 3 to 2, AP is going to be a little bit longer than PB, but it's going to be somewhere close to the middle. So finding this exact point, that's a little tough. How am I going to do that? So essentially, what I want to do is I want AP to be 3 parts and PB to be 3 parts. So if I'm thinking of this line over here, I'm just kind of thinking of this in my head. This is what's going through my brain right now. And I'm going to make my line. So I want A to P to kind of be like 3. And P to B to kind of be like 2. So this is 3 parts to 2 parts. So essentially I want to divide up the line into 5 equal parts. And I'm getting that 5 by doing 3 plus 2. Okay, so I want to divide up this line into 5 equal parts. Well, I don't know how to even begin to divide this line into 5 equal parts. I guess I could count out and down and kind of figure it out from there, guess and test. But I'm going to use the side splitter theorem to help me out. And the side splitter theorem is going to be immensely important. Okay? I'm going to make 3 parallel lines to help me out. Here's one of my parallel lines. Here's another one of my parallel lines. Okay, and my last parallel line will go through P, so it'll go through somewhere through this area here. And I want to figure that out. Well, I know I have to partition this into 5 equal parts, but if I'm looking at this line, which let me grab a different colored marker. Do I have one handy? I don't. So if I think of these as my 2 transversals, okay, if I was able to partition this transversal into 5 equal parts, then I should be able to draw some parallel lines to help me partition this transversal into 5 equal parts. Because that side splitter theorem, remember, kind of said that if I had 3 parallel lines, which I know my P is going to be, my line for P is going to go somewhere through here, okay, then I could partition them into equal ratios. So I could kind of, if I partitioned this into 3 to 2 and drew a vertical line through it, that would also partition AB into 3 to 2. So I'm going to partition this little segment down here into a 3 to 2 ratio, which means I need to partition it into 5 equal parts. So I'm going to count, and this is a line that I just dropped down straight from A. I'm going to count from here to here and then divide by 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 divided by 5 is 3. So 3 boxes, each part will be 3 long, so each of my 5 parts will be 3 long. So there's 1, 2, 3, 4, 5. So now I've divided this line down here into 5 equal parts. Well, if I wanted to divide it into a 3 to 2 ratio, I need 3 equal parts on one side and 2 equal parts on the other. So here's 1, 2, 3 equal parts and 2 equal parts on the other. So I'm going to draw my parallel vertical line through this point right here. And what this line will do is since it's parallel to these two other points, and these are transversals, it'll partition this line segment into the same ratio as this line segment was partitioned to. So this parallel line right here partitions this bottom line into a 3:2 ratio. It'll also partition this transversal into 3:2 ratio. So this point right here, that's the point. That's 3, 6, 9, 9, 4. That will be P. That will partition my line AB into a 3:2 ratio. Okay, so I'm going to do this with a couple more problems, and I want you guys to try them with me. Okay, so here's the next problem. Partition EF with endpoints -6, -4, and F 8, 3. Using point G, excuse me, I should say by finding point G. So that EG compared to GF is in the proportion of 3:4. Okay? So I'm going to make this graph again. Let me draw on this segment. So again, I want to partition this so that G makes it a 3:4 ratio. So when I look at this, G is going to be a little bit closer to E than it is to F, because EG is shorter than GF. So I'm thinking it's going to be somewhere in this area. That's kind of my thought process on this. So when I look at this, when I'm thinking out loud, E to G should be 3, 1, 2, 3. And then G to F should be 4, 1, 2, 3, 4. So I'm just kind of brainstorming here. That's 7 equal parts, because 3 plus 4 equals 7 equal parts. Okay, so I know I'm going to have to kind of look at 7 equal parts. I need to divide this into 7 pieces and put 3 of them closer to E and 4 of them closer to F, and that's where my G will end up being. So I kind of need that straight line, because again, this sloped line, that's not going to, like, I can't easily divide this up. So I need to make a straight line somehow, and I don't have a nice x-axis to do it with like on the last one, so I'm going to make a little right triangle out of all this. So I'm going to make a little right triangle. Okay, and what I'm going to do is I'm going to pick one of these lines to partition into 7 equal pieces, and then I'm going to have my 2 parallels, right? I've got this parallel line right here, and this parallel line right here. Okay? And that third parallel line is going to go somewhere in here, and it's going to make that partition. But first I have to divide this into 7 equal pieces. So I'm going to count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 little squares between this end and this end. So 14 divided by 7 is 2. So each little piece should be 2. So there's 2, 2, 2, 2, 2, 2, 2. Alright, so I want to partition this into a 3 to 4 ratio. So I need to count over 3 from the E side. So this is my E side. 1, 2, 3. And there should be 4 left on the other side. 1, 2, 3, 4. Yep, there's 4 pieces left on the other side. So this is the line where G should be on. I'm going to draw that parallel line parallel to the other two. And it should go through point G. So G would be 0, remember x first, and then down 1 is negative 1, y. Okay, that partitions. Remember, if I partition this into a ratio and I draw a parallel line, this is going to be partitioned into the same ratio. Alright, let's do one more. And if you want to pause the video and make sure you're doing it right before I do it, that's cool too. Okay? So I'm going to do one more. Yeah. Alright, so locate E on CD such that CE in proportion to ED is 3 to 5. C is -5, -6, and D is 11, 18. So if you want to pause the video right now and do this on your own, that would be a good idea. Then check back in and see if you match my work. I'm going to just keep going. So if you want to pause it and do it, pause now. Okay, I'm going to do it. So I'm making my graph here kind of big because I got to go all the way up to 18. 2, 4. So there's C. And then D is going to be 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, and I'm going to connect those two. See? Good thing we saved a whole piece of paper for this. Kind of a jerk that I didn't warn you that it would be this big, aren't I? Alright. So there's that line. Now I want to make that right triangle so I can partition one easy piece up to the right number. So I'm going to make my little right triangle over here. So, if I'm thinking I want a ratio of 3 to 5, so just kind of brainstorming out in my head, C, and then 1, 2, 3 to E, then 1, 2, 3, 4, 5 to D, it looks like to make this 3 to 5 partition, I'm going to need 8 equal pieces. Alright, so I'm going to cut this into 8 equal pieces. So I'm going to draw my 2 parallel lines. And if you're saying, Mrs. Northrop, but you don't really need to draw these parallel lines, you're right, but I want to keep that connection to the side splitter theorem, which is letting us do this. So I want to partition this piece into 8 equal pieces. Now, what if this happens where it doesn't break up into 8, like something that's divisible by 8? You can always check on this line and see if this would break into 8, and then count them out, and then go this way with your line. That's fine too, as long as your lines are parallel. But I'm going to hope that this works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ha, it does work. So 16 divided by 8 is 2. So 2, 4, 6, 8, 10, 12, 14. I guess I missed something. I guess I didn't really guesstimate where E might be. So if I look at this, E is going to be closer to C because 3 is smaller than 5. So E is going to be closer to C than D. So I'm guessing, somewhere in this area, a little bit less than half. So I'm going to go over 3 equal spots. 1, 2, 3. Are there 5 left on the other side? 1, 2, 3, 4, 5. Yep. So that's good. So that's where I'm going to draw my parallel line through. And using that side splitter formula, you can see that here, or theorem, I can see that that is where E should be. So it's 1, 3 is E. Okay? So that's it. I'm sorry that this video is longer than intended, but that's the idea for tomorrow.